In this video we will see a matrix of random values, row reduced echelon form, colon operators, and by using colon operators increment and decrement, transpose of a matrix, transpose of complex matrices, and how to take absolute of a complex number, then how to represent complex numbers in MATLAB, then square root and exponential, and then how to take the power of any number, and how to multiply two matrices in the form that will get the square of a matrix. And let's begin. Here we are having a matrix A of order 3 by 3. To check order, let's use size operator, size function. Size of A. So let me tell you one thing. In home tab and in preferences, then go to fonts, and from here you can change the style of your editor window. Here we are having a matrix A of order 3 cross 3. Let's say I want to take a square of matrix A. Let's say let's store the result in, for square we use hat operator, square. Let's see, and here I am having Q1 and Control C, Control V. Here I am having Q2 and here I am having dot. So let's check the result of both of these. Editor, run this. We can run our code by pressing F5 or manually. So let's check what is Q1. We are having Q1 like this and Q2. We are having Q2 like this. And let's check now some matrix A. So if you can see here, when we are using hat operator without a dot, then we are getting matrix multiplication, and if we are using hat operator with a dot, then we are getting point to point multiplication of a matrix A with itself. So if you want that each and every entry of matrix, and here we are having a matrix A, and clear command, then in similar way, if you want to take let's comment this by using Control R. If you want to take the square of any number, let's say I want to take the square of 2 raised to power 10, I will use hat operator 2 raised to power 10 and store it in A, and let's check. I am getting the result 10 raised to power 24. In similar way, you can take the square root of any number by using hat operator. And then if I want to write exponential, I can write that in MATLAB. First of all, let's check what is exponential. If I am using a semicolon here, then I will not be able, then what will happen, it will terminate and the result will not be shown in command window. And if I don't terminate this, then I will be able to show the result in command window directly. So here 1 multiply e raised to e square f5. So here you can see I am getting 100 by using exponential, and the value of exponential we know it's 2.7, it's 2.7 something like that. Then let's move forward to let's terminate this. And if I want to take the square root of this as, and I can save the result in the same variable, it will get updated square root of a f5, and here you can see I am having the result of updated a that is shown in workspace also. Let's check this in command window. Here I am having a equals to 10. Now let's move forward to complex numbers. How to write a complex number? If I do this square root of any negative number gives us complex number. Let's check this. Here you can see a is a complex number having 0 real value and 1 imaginary value, and I and j are reserved variables for complex numbers. Means to say that if we are using I and j in any matrix, then our tool will consider it a complex number. Let's make a matrix of complex numbers. 1 plus 2 I 3 plus 7 I. Then let's copy this, Control C, Control V. Here I am having negative 17 and 12. So let's check. Here we are having a matrix of order 2 plus 2. Let's also change its symbol. Here we minus, here also minus, and here plus. Now if we take transpose of a complex number, it is a bit different than others. Let's do this. And let's say I am having q1 equals to a apostrophe, and let's q2 equals to capital A dot transpose. There is difference in both of them. What's the difference? Let's check. First of all, let's check A, then Q1, then Q2. So what's the difference? If we are using simple apostrophe, means to say if we take transpose without a dot operator, then what happens? We are getting the conjugate of each and every complex number. You can see here transpose these values will be interchanged with each other, okay, but every value is the conjugate of the original value. And here if we use a dot operator, then what will happen? If we take transpose with a dot operator, then it is transposed, but it is not conjugate transpose. So that is the difference. Now if you want to take if I take the absolute of this complex number, absolute means the magnitude of each complex number. Let's check here what is A we are having. So how the result I get this result 1 square plus 2 square under root, and this is under root 5 answer. By simplifying this, we will get under root 5 equals 2.2361. Then we are having very important colon operator or range operator, we can say this also. How to use this? Let's say someone says you to that I want 1000 values starting from 1 to 1000, and it must consist each and every number in between 1 and 1000. Then how you will do this? Let's do that. 1 colon 1000. It will generate a row matrix of 1000 columns. So let's check what we are having here. First, let's check the size of this matrix A. The size of this matrix A is R equals to 1, C equals to 1000. So it is a row matrix of 1000 columns. Then here we can also change, we can increment in this, we can shorten the range of this A matrix. Let's say I say that I want 500 values between 1000. So how we do that? Let's say I want 500 values between 0 and 1000, and all the values that are even numbers. Let's do that. Let's check this A. what I am getting here. Starting from 0, then it will increment 2, 4, 6, 8, 10, 12, and so on up to 1000. And in similar way we can also decrement this. For decrement we need to mention that we are decrementing by -2, and let's say we are having here 100. For decrement the starting number must be greater than the ending number. Let's run this and check A. So you can see the last ending number is 100 and starting number will be 1000, and then decrement of 2 is in every value. So we can range operator or column operator is used instead of loops. Let's take a matrix A, capital A equals to sorry, I think I have not told you that we can make a random matrix of any order, and I want a 2 cross 3 random matrix of order 2 cross 3. Let me show you a matrix. So you can see here A is a matrix of random values between 0 and 1. So it is a limitation of random function that it is limited to 0 and 1. We can change its range by addition, subtraction, and multiplication. Let's say I multiply, let's say I add 1 in this. Now if I test this in command window, here you can say no, it's not limited between 0 and 1. So we can change its limit according to requirement. And now if I say that I want to check the row reduced echelon form of this matrix A, for that I have to use function row reduced echelon form of capital matrix A. That's F5. Here I am having now a matrix A. Let's check this. Let's take, here you can see it will be clear in a scale matrix row reduced echelon form, and here you can see row reduced echelon form of matrix A. So this was all about this lecture. We have covered a lot of very few built-in functions, and that's all for today.